Hello, in this video we are going to go ahead and look at arithmetic and geometric sequences from context. Our objective is to write the explicit and recursive process from context. Please remember to go ahead and write down the objective. For prior knowledge, we are given a sequence and we're asked, is the function arithmetic or geometric? Remember, if a sequence is arithmetic, it has a common difference, or it has a d value. Pretty much we are adding or we are subtracting. Now, for a geometric sequence, it has a common ratio, and that's called an R value. So an R value, that's where you multiply or we are dividing. Looking at this sequence, the numbers are, first term's 3, second term is 6, third term is 12, and the fourth term is 24. So 3 to 6, I'm either adding 3 or I'm multiplying by 2. 6 to 12, I'm definitely at this point multiplying by 2. So here I have a R value, a common ratio of 2. So this is an arithmetic sequence. Sorry, geometric. My bad, geometric. For the second sequence here, I would like you to go ahead and identify as it arithmetic or geometric and come up with the d value or the r value. So go ahead and try that one on your own right now. Okay, so looking at this guy, 3 to 6, well, I'm either multiplying by 2 again or I'm adding 3. 6 to 9, I'm definitely adding 3 at this point. Therefore, this is arithmetic, and I have a d value that is equal to 3. In addition to your notes, I have passed out to you a concept map that looks like this. Now, we're going to go ahead and use this today in these types of problems, and what I want to point out is that this whole piece right here, this whole box, deals with arithmetic sequences. We haven't talked much about the graphing portion. We haven't talked about this, but arithmetic sequences are linear. We have a constant rate of change represented by the common difference here, the d value. Now what I would like you to do is I would like you to go ahead and box this area. F of 0 equals box, and f of x equals f of x minus 1 plus or minus d. Box, put a box there. I'm having you box this because throughout this lesson you're going to need to find two things. You're always going to have to find f of 0, and you're always going to have to find d or r. Now here, f of 0, box, you're going to put in f of 0, and for this portion, the second line of your recursive process, you're going to plug in the common difference. Now this is the recursive process for arithmetic sequence, and here I have the explicit process. Go ahead for the explicit process, can you please box that d, and then box the f of 0. So here are the two values that you're going to input, d times x plus the f of 0 value. Now for a geometric sequence, this is all our geometric sequence. I have the recursive process. Again, box f of 0. F of 0 equals box. And then f of x is equal to r times f of x minus 1. So I take that previous term and I multiply by the ratio, the r value. So box that r. And then do the same thing here for the explicit process. So this takes us directly to any term we want. F of 0. Box that, and the r value, go ahead and box. So after you have boxed these values, I really want to point out that here, these are the recursive process. So this is how this chart works. This is the recursive process for arithmetic and geometric sequences. This is the explicit process for arithmetic and geometric sequences. This row here applies specifically for arithmetic sequences, and then the bottom row down here is for geometric sequences, okay? So if I wanted the recursive process for an arithmetic sequence, it'd be this box. If I wanted the explicit process for a geometric sequence, it would be this box. Okay, so that's kind of how this chart works, and we're going to use this today. So going back to our notes, this is example 1. Please fill in the values for this problem. It says, example 1, you borrow $500 from a relative and you agree to pay back the debt at a rate of $15 per month. So we need to determine if this sequence is arithmetic or not, or geometric. So we start off with money, and initially we have borrowed $500. So that is negative 500. This is my 0th term. And then I pay back at a rate of 15. So I'm adding $15. So negative 500 plus 15 would be negative 485 plus 15, that would be negative 470, so on and so forth. So you can tell if we're paying back at a rate of $15 per month, that is adding $15 per month, so therefore our sequence is arithmetic. So we're going to say arithmetic. Then it says create a recursive process for the sequence. So looking at our concept map, here we go. Notice I want the recursive process for an arithmetic sequence. That's this box right here. So I need to go ahead and I need to find two things. I need to find f of 0 and I need to find the d value. F of 0 and the d value. So looking at our problem, our f of 0 in this case, and this is how you write it, f of 0 equals, well, that is equal to negative 500. And f of x is equal to f of x minus 1, and then plus the d value. And in this case, our d value is 15, so I add 15. Notice how I put these in red. That's the only part you fill in. This line is always present with f0. This line is always present. F of x equals f of x minus 1. Okay, so that's the recursive process. Step 3. We're going to go ahead and create an explicit process for this sequence. So again, looking at our concept map, here the explicit process is f of x equals d times x plus f of 0. So I have f of x equals d times x, and my d value is 15, so 15 times x plus f of 0, and here f of 0 is negative 500, so I put minus 500, and that's my explicit process. Number 4, it says how much money do you owe after 20 months? 20 months. So what we're going to do is we're going to evaluate this function, f of x, and we're going to evaluate for 20. And let me color code this to help you kind of see what's going on. So f of, and we want 20. So I'm going to drop in 20. And I have, well, my explicit process is 15 times x. So instead of x, I'm going to replace it with 20. And I'm going to subtract 500. So 20. Okay. And what I want to do is I want to go ahead and solve this. So 15 times 20, that is 300. Minus 500 gives me negative 200. And we want to answer this in a complete sentence, this question. So we would say, after 20 months, I would owe $200. Okay, on these ones, you want to make sure that you always answer in a complete sentence. Okay, next example, example 2. This problem says Zika is a disease that contains flu-like symptoms and results with babies being born with a small head and brain damage. In 2015, there were 3,000 cases reported, which was 20 times more than the initial value of 150 cases in 2014. When reading problems, it's a very good idea to box key information. So this says in 2015, there were 3,000 cases, which was cases reported, which was 20 times more than the initial value of 150 cases in 2014. So in this problem, this one's kind of tricky. What we want to do is we kind of want to make a table. I'm going to say this is X, this is going to represent our years, and the initial value is 2014. Okay, so this is essentially our 0th term, and there were 150 cases present there. After 1 year in 2015, there were 3,000 cases. And they say this was 20 times more. So that right there tells you here we are multiplying by 20. So therefore this is a geometric sequence. And I have a R value of 20. Additionally, looking at this table, they say the initial value was 150. The initial value. So therefore f of 0 is 150 cases. So what we're going to do is we're going to create a recursive process. Remember, look at your concept map if you struggle, but I need f of 0, and that was 150, and I need f of x. Well, f of x is generated from the previous term, f of x minus 1, and then the pattern that's going on with the sequence is that we multiply it by 20. Now I want to create my explicit process, and looking at my concept map, the explicit process is f of x equals f of 0 times r to the x power. So I have f of x is equal to f of 0, which is 150, times r, which is 20 to the x power. So that's my explicit process. And then last but not least, it says how many cases would be reported in 2020. So in 2020, I need to figure out, okay, how many years after the initial value is, or what term is this? So I'm going to go back up here to my table. 2015 is the first term. 2016 is the second term. 17 would be the third term. 18 would be the fourth term. I'm going to go over here. Our fifth term would be 2019, and so our sixth term would be 2020. So you could do this a couple of ways. You could recount this recursively. You could continue to multiply by 20, or you can evaluate the function at 6. So f of 6 is equal to 150 times 20 to the power of 6. So you can use your calculator, and I'm going to go ahead and use mine. So let me cover up Beetlejuice over here. 20 to the power of, and here we go, here's my exponent. So 20 to the power of 6 is equal to that value. And I'm going to multiply that by 150, and boom. Here we go. So 9, 6, and then a lot of zeros. Let's count how many zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. So this is 9, 6 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we have, well, this is thousands, millions, billion, 9,600,000,000 cases in 2020 of Zika. We'll see. Okay, this is a context problem, so we want to write it in a sentence. So in 2020, there will be